All right, so quickly going over 10.3 areas of all triangles. So when we talked about areas of all triangles, we kind of did a quick geometry review. So going over your geometry as far as what did you learn in geometry? So first, talking about the triangle inequality theorem about testing if three sides make up of a triangle. So three sides can make up of a triangle as long as two sides are the sum of two sides is always greater than one side by itself. So if you look right here at example, we have 12, 11, and 17. And you can see here that at all times, the sum of two sides is always greater than one of the sides. Okay. Next, we started talking about how you started learning area of a triangle. So start off simple with area equals base times height divided by 2. And you start off with a 90-degree angle. So a right triangle. Then you progress to a triangle with the height not being, a triangle of anything other than a right triangle, and the height being in the center. Then they're like, oh, your height can also be on the outside. And if you had a really great teacher, they made that connection to it being related to a rectangle and how that all comes together. Okay. Now, here we are. What if it's not a right triangle and you are not given the height? What do we do? Well, the first option is that we had Heron's formulas. And with Heron's formula, the Greek mathematician discovered that if you find your semi-perimeter, and what is your semi-perimeter, you ask? The semi-perimeter is the sum of your sides divided by 2. Once you find that value and plug it into Heron's area formula, it'll give you the value of your area for that triangle, okay? So here was our example that we did. So in the example, we went through and we talked about, okay, we know that we have A, B, C. All I did was order them from least to greatest. I labeled them from least to greatest. So first part is to find our S. So we found our S, 9 plus 10 plus 11 divided by 2. 30 divided by 2 gives us 15. After we found our S, we plugged it into the formula, the second formula, and plugged in our sides A, B, and C. Okay, I like to simplify. So before I went to a calculator, I did as much as I could in my brain. So I did 15 minus 9 is 6. 15 minus 10 is 5. 15 minus 11 is 4. Then I multiplied, and I got 60 times 30 is 1,800. Okay, this is where my brain was like, ooh, we need a calculator. So then we use the calculator to find the square root of that. And that's how we got our area, okay? So then I had you guys practice, and you're like, this is super easy. And you found the area of this triangle with all three sides, okay? Now, area of oblique triangles without all sides. What do we do? Well, Heron used law of cosines. For us, someone discovered that you also can use sine if you're given this situation, side, angle, side. That means you're given the value of an angle and the two sides that make up that angle, okay? Or two sides and their included angle. However you want to read it, but that's how it works, okay? So, area with sine. I check to make sure I have the right information. I have a side, an angle, and a side. Perfect. So when I'm plugging these values in, I'm going to plug them in based on the formula. This formula changes based on how you have labeled your angles and your side, okay? But basically what it is, it's half the product of your two included sides times the sine of the included angle, okay? By doing that, plugging everything in, using the calculator, you're able to find the area, okay? So then you guys did it on your own, and you drew your own triangle, you use your measurements, and you plugged in, and you found the area. So that's the quick sum of 10.3.